Most students face a lot of challenges when it comes to deriving formulas using polyatomic ions. Today in this video, I'm going to be showing you exactly how we can derive formulas using polyatomic ions and what polyatomic ions are. You are going to know everything about polyatomic ions. And before we begin, what are polyatomic ions? We are talking about polyatomic ions. What are they? Polyatomic ions are simply a group of elements or group of atoms coming together and behaving like a single atom, having a single charge and a single valency. Those are polyatomic ions. We have so many of them. We mostly use them in chemistry. When writing equations, we always find polyatomic ions being used. You can't do chemistry without knowing how to derive formulas, especially formulas dealing with polyatomic ions. We have some few examples of polyatomic ions. Let me list them. We have ammonium ion is a polyatomic ion. Ammonium. NH4 is a polyatomic ion. Ammonium ion. We also have nitrate ion. This is a nitrate ion, which is a polyatomic ion. You can see that these are two atoms. For ammonium, you have nitrogen and hydrogen coming together and behaving like a single atom with a single charge. Unlike some elements like sodium, calcium, and magnesium, which are just made of one single atom with a charge, these ones are made of two atoms with charges as well. You can have nitrate. Let's talk of carbonate. Carbonate is a polyatomic ion as well. You can also talk of hydroxide with a minus charge. This is a polyatomic ion. You can also have sulphate ion. Sulphate ion, SO₄². It's a polyatomic ion. Just to name a few, we have many polyatomic ions which you can use in deriving formulas. So I'm going to be taking you through a series of examples on how we can derive formulas using polyatomic ions. For example, let's derive a formula which is made of an atom and a polyatomic ions like sodium sulfate. Before doing this, you have to know the basic rules which are used in deriving chemical formulas. To derive chemical formula, you have to write their elements, write their valencies, and interchange the elements and their valencies. That is a simple rule we can use to derive formulas. To continue, let's talk about valencies. What are valencies? Because each element I was talking about, these polyatomic ions, they have a single valency. They have a single charge, even though they are made of two atoms, two separate atoms with a single valency. Now, what are valency? Valency is the number of atoms or the number of electrons an atom needs to either gain, lose, or share to be stable during bonding, during interaction, during combination. A valency also tells you the number of bonds an atom is going to form when it combines with another atom. There are a lot of things we can talk about when it concerns valency. Let's talk about the group 1 elements and their valency. All group 1 elements have a valency of 1. For example, sodium, which is a group 1 element, has a valence of 1. Potassium, which is a group 1 element, has a valence of 1. Lithium also has a valence of 1. These are the elements and their valencies for the alkaline metals. Let's go to the alkaline metal, earth metals, which are the group 2 elements. All group 2 element has a valence of 2. Magnesium is a group 2 element with a valence of 2. You can also talk of calcium, which is a group 2 element with a valence of 2. And many other elements also have a valence of 2, which falls under group 2 element, under alkaline earth metals. All group 7 elements has a valence of 1. They need to share or they need to gain 1 electron to be stable. To list some of the group 7 elements which are known as halogens, we can talk of fluorine. Fluorine, which is so reactive, we don't mostly use them. So fluorine has a valence of 1. Chlorine has a valence of 1 as well. Bromine has a valence of 1. Iodine also has a valence of 1. These are group 7 elements with their valencies. Sulfur has a valence of 2. You can also talk of aluminium. Aluminium has a valence of 3. These are some of the elements and their valencies. Now coming to polyatomic ions. When you see polyatomic ions, their valencies will be picked from the number which is associated with the charge. Yes, when you have ammonium plus, it means that this is a plus 1. So the 1 there is the valency of ammonium. So ammonium ion has a valency of 1. You can talk of nitrate. Nitrate ion is minus. It means nitrate has a valency of 1 because this is like minus 1, but we don't write minus 1. We write only minus. And coming to carbonate. Carbonate is 2 minus. It means that this minus sign or this 2 is the valency of carbonate. The number beside the charge is the valency of polyatomic ions. You can also talk of hydroxide, which is minus. It means that you have minus 1, and the 1 there is the valency of hydroxide. sulphate as well. Sulphate is 2 minus or minus 2. Now let's give some few examples and derive their formulas. This is the first one we said, sodium sulphate. Let's derive the formula of sodium sulphate. When deriving the formula, you have to choose the elements which are involved. In sodium sulphate, you have sodium, which is an element, and you also have sulphate, which is a polyatomic ion. The two are combining together. So I'm going to write sodium first. Sodium, the symbol of sodium is Na with its valency. Its valency is 1. I'm also going to write sulphate. This is how sulphate is being written. Sulphate without the charge. This is a polyatomic ion. I'm not going to write the charge. Yes, I'm going to write its valency, which is 2. Sulphate, sodium sulphate. Now, after writing this, you are going to cross multiply. This element, this symbol of element, take this valency. This other one takes the valency here. But something you have to note here, some formulas containing polyatomic ions are always in brackets. If a polyatomic ion is taking a valency which is more than 1, you put that polyatomic ion in brackets before writing the valency. So if I want to write this, I'm going to have sodium taking a valency of 2, like we have seen. Sodium with a valency of 2, it's going to be sodium 2, and sulphate, it's a polyatomic ion like this, taking a valence of 1. You could see it's like this. It's supposed to take a valence of 1 here. Let me just write it. Valence of 1. But this one is insignificant. If you want to simplify to its lowest form, sodium sulphate comes down to sodium sulphate. That is the right formula of sodium sulphate. Let's derive another formula, which is the formula of, let me say, ammonium nitrate. Let's use ammonium nitrate. Ammonium nitrate. Let's derive the formula of ammonium nitrate. So looking at this, we have 2 polyatomic ions coming together in that formula, ammonium and nitrate. So you are going to write ammonium first. Ammonium NH4 without its charge. You are going to exclude the charge and write its valency. I told you what the valency comes about. The number beside the charge is the valency. So the valency of ammonium is 1. Write it there. You're also going to write the next polyatomic ion, which is a nitrate ion. So nitrate is written like this. With its charge, the number beside the charge is the valency, which is 1 as well. So ammonium nitrate is like this. You are going to cross multiply. This ammonium takes the valency this nitrate takes this valency. So it's going to be ammonium NH4 was supposed to take 1, and nitrate is also going to take 1. But 1 and 1, you want to simplify to its lowest form. There is no need for you to write 1, so it's just going to be ammonium nitrate. Yes, this is how you write ammonium nitrate. Now let's derive the formula of ammonium carbonate. This is a compound. To derive its formula, it's also made up of 2 polyatomic ions. The atomic ions of called ammonium and that called carbonate. So we are going to write ammonium as well. Ammonium with its valency 1. And carbonate, you can see that carbonate has a valence of 2. Carbonate with a valence of 2. So if you want to cross multiply, you are going to see that ammonium takes the valency of carbonate, which is 2. You are going to have ammonium taking a valency of carbonate, which is 2. Like I said earlier, when a polyatomic ion is taking a valency which is more than 1, you always have to put it in bracket before you put that valency. Put it in bracket before putting that valency. And you also have carbonate, not equal to here. Carbonate taking a valence of 1. There's no need to put 1, but let me just put for demonstration purposes. So ammonium carbonate will be like this. Ammonium with 2 and carbonate like this. This is the right formula of ammonium carbonate. Ammonium nitrate, are we doing that? Let's put ammonium nitrate. Yes, we have already done ammonium nitrate, right? Okay, now let's derive the formula of sodium hydroxide. I will use this small space. Sodium hydroxide is made of sodium and hydroxide. Sodium like this, Na, which is a single element with a valency of 1 because it's a group 1 element. And you also have hydroxide, which is OH with a valency of 1. That is why you have the formula of sodium hydroxide to be like this, because each element involved is having a valency of 1. Sodium takes 1, hydroxide takes 1. So the formula boils down to sodium hydroxide. Let's put magnesium hydroxide. Let's write the formula of magnesium hydroxide. So I'm going to use this other space down here to write the formula of magnesium hydroxide. So magnesium hydroxide. Looking at this, you see that magnesium is a group 2 element, while hydroxide is a polyatomic ion. So to write this, I'm going to write the symbol of magnesium Mg, and its valency is 2. Hydroxide is OH, the valency is 1. So cross multiply. Magnesium takes this valency 1, magnesium 1, hydroxide, a polyatomic ion, taking a valency which is 2. We put in brackets because the valency is more than 1. That is why you are putting in bracket. So the formula boils down to magnesium hydroxide in bracket. That is why you always find brackets like this. Hydrogen sulfate, which is commonly known as sulfuric acid. Hydrogen sulfate, you can call it sulfuric acid. Now, hydrogen sulfate is made of hydrogen and sulfate, which is a polyatomic ion. Hydrogen, I'm going to write hydrogen H with a valence of 1. And sulfate, we will write sulfate here, sulfate ion, with the valence of 2. So if you cross multiply like this, you are going to notice that hydrogen sulfate will be written as H taking 2. H is taking the valence of sulfate, and sulfate taking a valency of hydrogen, which is 1. There is no need for us to write it. That is why you always find the formula of sulfuric acid written like this, and the chemical name, the standard name for sulfuric acid, is known as hydrogen sulfate. Let's derive that from the magnesium carbonate. Magnesium carbonate, magnesium and carbonate. So magnesium is Mg, right? Magnesium is Mg with the valency of 2, is a group 2 element, and carbonate like this, C with a valency of 2, magnesium carbonate. So if you cross multiply this, it's going to be magnesium 2, carbonate 2 as well, carbonate 2. But this 2, if you want to simplify to their lowest form, this 2 can cancel this 2. So it's going to come back to magnesium carbonate. This is the right form of magnesium carbonate. Drawing that from magnesium nitrate, let's look at magnesium nitrate. Magnesium nitrate is Mg2 and nitrate NO3, a polyatomic ion with a valence of 1. Cross multiply, you are going to have magnesium 1, nitrate taking a valency which is more than 1, 2. So the right formula, because this one is not necessary for us to write 1 there. We all know that magnesium is 1 magnesium. So magnesium is magnesium nitrate. This is the right formula of magnesium nitrate, like this. Yes, this is how you derive chemical formulas using polyatomic ions. If you have any doubt, any worry, drop it at the comment section. I'm going to reply to you. And of course, if you have any challenge with any topic in chemistry, make sure that you drop at the comment section. I'm going to do a video for you, and it's going to help you overcome your challenges. Subscribe to this channel, hit the like button, hit the notification bell, so that you are going to be the first person to be notified whenever I upload a video on this channel.